Hey guys, welcome to Shekar YouTube channel. Today we are going to discuss about chapter 1. In BWE, chapter 1, unit 1 is DC circuits. DC means direct current. So the total unit we are discussing about DC only. So direct current, DC circuits. So in the DC circuit, in the examination point of view, you will be asked about the question like that electrical circuit elements. You are supposed to explain about basic electrical circuit elements. It means what are the electrical circuits. Now we have three elements. So we have basically three elements of basic electrical circuits, which are resistance, which is denoted by capital R, inductance, and it is denoted by capital L, and capacitance in C. So these are the basic three elements of electrical circuits. So you are supposed to explain about each one of them. First, let us see resistance. Resistance, first you have to write the definition. The property of a material which opposes flow of current through it. So what is the definition? What it does? It does opposes, nothing but when the current is flowing through the circuit and which is opposes so the flow of current through it. For example, let us see, this is the resistance. The symbol of the resistance is this one. So what is the definition? Whenever current passing through it means resistance. Property, this property of the resistance which opposes the flow of current through it. So this is the definition of the resistance. Next you have to write about unit. Unit of the resistance is ohm. The symbol is ohms. This one. This is the symbol of the ohm. Next you have to write the formula. So according to the Ohm's law, I explained Ohm's law in the first video. So the basic definition and formula is I is equal to V by R. From this equation we can write resistance formula R is equal to V by I. So this is the basic definition of the formula. Next. So after formula, you are supposed to write loss of resistance. What is the mean by loss of resistance? So which means if you take this is the, for example, this is a conductor. Okay. So this is a conductor length and this is the area of the cross section. So what loss is saying? The resistance is directly proportional to length of the conductor, where L is equal to length of the conductor. So it means when length increases, resistance of the conductor also increases. When length decreases, resistance also decreases. This is the directly proportional relation to the length of the conductor. Let us say this is equation number 1. Next, resistance is inversely proportional to the area of the cross section, where small a is equal to area of the cross section. Let us see, this is the equation number 2. So these are the two laws of the resistance. So when you take this conductor, when the length increases, the resistance of the conductor also increases. And cross sectional area, when cross sectional area increases, the resistance will be decreases. So it is a inversely proportional. So these are the two equations. So from the equation 1 and 2, we can write R is directly proportional to L and inversely proportional to area of the cross section. If we remove this proportionality, we can write R is equal to rho L by A, where rho is called proportional constant, or it can also be called as specific resistance of the given material. So aluminum and the copper will be having different types of conductors. So it depends upon the material. It is be given the rho is nothing but a specific resistance. So where rho is equal to, if you rewrite this equation, so RA divided by L. So from this equation, you can write rho is equal to RA divided by L. So if you see the units of the specific resistance, what is the unit of or resistance? Ohm, right? What is the unit of cross-sectional area? Meter square. The unit of length is meter. So here 1 meter gets cancelled. So the final unit of specific resistance is ohm meter. This is also one of the important. And next you have to explain about power formula. What is the power formula for the resistance? So power nothing but generally the product of voltage into current. So volt ampere, so which means watt. So it is represented by W. The unit of power is watt. So means when you connect this resistance to the supply, and so supply is voltage, then immediately current will flows. So the product of voltage and current represents and the power of this circuit. Okay, so therefore we can write power P is equal to VI. So in DC circuit we write only VI. If you go this actually power equation V into cos phi, that's a different. In DC circuits the power equation is equal to VI only. So this is about the power formula. Next. So next you have to explain about phasor diagram. What is meant by phasor diagram? The relation between voltage and current, the angle between voltage and current. So it means whenever the resistance connected to the supply, so now the circuit is having only resistance. So when it's connected to the supply, the phase angle, so this is a voltage, this is a current. The phase angle between voltage and current tells about the phasor diagram, phase angle. So in pure resistance, the phase angle is equal to 0. So as I said, so actually the power equation if you write in AC circuit, P is equal to V into cos phi, generally we write. This is the main power equation of this AC circuit. So here in DC circuit what happens? When the pure resistance, the power factor is equal to 1, which means the cos, so I explained here, the cos pi is equal to 1, which means cos 0 is equal to 1, which you know already this formula, okay? Cos 0 is equal to 1. So here the angle is 0, which means the voltage and current both are flowing in phase. In phase nothing but in the same phase, there is no difference. That is the main concept here. So both are flowing in phase. There is no phase angle difference. That is called, we can write, so we can say unity power factor. Unity power factor means, so the phase angle is 0. Both are flowing in phase. There is, when theta is equal to 0, there is no lag or lead, which means either the current or voltage are flowing one after the other. So they are flowing in phase. They are not flowing one after the other. So which is the, there is no lead and lag. Lag means it's after, lead means which comes first. So I will explain in detail later. Simply here is, you remember that phasor diagram of resistance nothing but it has unity power factor. The both voltage and current flows in phase. So this you have to remember. Okay. So this is the theory, this is the information about the resistance. So similarly you have to write about the inductance. Next see the inductance. Now let's see the inductance. So next material is, so inductance is nothing but L. So let us see the definition. The property of a material which opposes any change in magnitude or direction of the current passing through it, which means the property of the inductance, what is doing, which is opposing magnitude of the current. For example, 3 amperes to 4 amperes or 4 amperes to 3 amperes. This is the magnitude of the current, and it opposes the magnitude of the current and direction also. If you want to blow like this, clockwise to anti-clockwise, so like this, direction also changes. So this change is opposes, this changing magnitude and direction opposed by whom? Inductance. That is the property of the material. So next, this is the definition you are supposed to write in the exam. Okay. And next, symbol of the inductance, this is the symbol. So this is the inductance which is opposing sudden change in direction and magnitude of the current. So whenever you need the change is required, so we have to use this the inductance. Okay. The unit of inductance is Henry. The letter H, capital H. So we can denote it by the letter capital H. And next, you should write voltage equation of the inductance. The V is equal to L into di by dt. What is the L? Inductance of the material. Di by dt nothing but change in current. The rate of change in current. So the next, power equation. Power P is equal to what I told just now. Power P is equal to voltage into current. So you write just what is a V? L di by dt. So just you substitute this a V value here, L into di by dt and I. So the total equation is Li di by dt. So what is the power unit? Watt. So this is the watt. Next you have to write about phasor diagram. As I told, what is a phasor diagram? The phase angle between voltage and current. When you connect the pure inductance, for example, this is a pure inductance, right? If you connect to this supply or battery, okay, positive and negative, and then current passes, right? So this is the, we are talking about the voltage current relation, phasor diagram. So first what happens, the phase angle between this voltage and current is 90 degrees. So first v leads I by 90 degrees, which is flowing first, leading nothing but first. So what is here? Voltage. This is a voltage which is leading to whom? Which is leading? Current. So first voltage is flowing, then current. So this phase angle between these two, because voltage current is, what is the vector diagram? Okay, so it has both magnitude and direction. So therefore here the phase difference is 90 degrees for pure inductance. So we can say V leads I by 90 degrees, or also we can say I lags V by 90 degrees. This is a phasor diagram. Next. So next you have to explain about capacitance. So capacitance, the letter denoted by C. So let's see the definition. The property of material which stores an electric charge within it. What is the capacitor? Capacitor nothing but storing element. How much energy is storing, that shows the capacitance. So the capacitance nothing but, you should write the property of the material which stores an electric charge within it. This is the definition you are supposed to write in the exam. But the symbol of this capacitor, so this is the symbol, positive and negative. So this here actually two plates are separated like this equally. So this is a symbol. Don't get confused with battery. Battery is having one symbol is positive is like this, and this is a negative. So this is a battery symbol. Capacitance, the equal, both plates should have equal amount. So this is the capacitance. And next, unit of the capacitance is farad, and the formula. So here C is equal to Q by V. So charge per volt, this is a capacitance. What is the formula? Charge. Q is the charge and per voltage. So this is the V. And from this equation, if you write current equation for this capacitance, current I is equal to C into dV by dt. What is the dV by dt? The rate of change of voltage. So when it is stored, when you apply the rate of change of voltage, so I is equal to C dV by dt. See, when you observe this exactly this inductance formula, so here what happened? So the L VL L di by dt. So just reverse. Okay, here I is equal to C dV by dt in capacitance. Inductance VL is equal to L di by dt. So in inductance, what is that? The rate of change of current. So in capacitance, you have to remember rate of change of voltage. These are the simple difference. Next, power equation. P is equal to VI. So what is the power equation? P is equal to voltage and current. So we know the current relation here. So P is equal to V into what's the current? C dV by dt. So just substitute and you will get the power equation. Next, you have to finally explain about the power phasor diagram. What is a phasor diagram? The phase angle between voltage and current, exactly opposite to the inductance. So theta is equal to 90 degrees between voltage and current. So here V is lagging by I by 90 degrees. So which is lagging? Lagging nothing but this is the lagging. This is a leading. So which comes first. Lead nothing but which is coming first, and lag nothing but which is coming later or after. So now we can write V lags I by 90 degrees, or overall I leads V by 90 degrees. So when compared to this V and I, which is going first? I is going first. So which is in the front, that we can call it as leading. So it has a big definition, but don't get confused. Just you remember, capacitance current is leading and inductance current is lagging. So we can explain like this. So this is enough. I hope you guys understand the basic elements of electrical circuits. First is the resistance, inductance, and capacitance. You are supposed to write in the exam. You'll get full marks. I hope you understand. Thank you so much. Love you all.